Welcome back, viewers. In the earlier videos, that is almost 1 year old, we had done a few videos and Podman and containers on videos. So we had installed the Ubuntu WSL on Windows 11. That is my machines. This same machine also has got Windows. So there are two partitions. One is Linux and one is Windows. So we had installed the Ubuntu WSL, and on that we had installed the container, and we had shown you how to operate the container. We had also done a video on Podman also in the same series. So now coming back to Linux, so we will from this video onwards we will discuss about the Linux containers and Docker. So Docker is also a type of container that we will come up later. First we will start with the Linux containers. So I have opened up this XTA developers web page regarding the Linux containers guide. So this is a guide, so we should go through the introduction. So containers are a method of running virtualized applications on your computer similar to virtual machines, but using a different set of underlying technologies. They can be complex to understand, but they are essential for running everything from the Minecraft servers to Google. And now we are going to show you how to set up them. So at the end of this discussion, we will also do the installation of Linux containers. So those containers we will try to install on my system, that is this Endeavour OS system that I am using for the video production for the channel. So we will be using Linux, an operating system built with focus on portability, modularity and stability. Linux is everything from servers to microwaves to video game consoles. Containers aren't limited to running on Linux, but technologies behind them are best suited to and best run on Linux. So if you are new to Linux, we recommend you to check the beginner's guide before diving. So there is a beginner's guide also. That also you can check, or maybe if required, I will make a separate video on that. Are containers virtual machines? So containers can be a complex topic, but it is best to start with a key point. A container is not a virtual machine. A virtual machine is a simulated version of specific hardware and its software that runs in what is known as a hypervisor. So if you are using software like a VirtualBox or multipass, then you are using a hypervisor. Now the hypervisor usually runs either as its own operating system, that is called a type 1 hypervisor, or it runs within the confines of another operating system like Windows or Ubuntu, that is a type 2 hypervisor. The hypervisor's responsibility is to present the guest operating system with simulated hardware it requires to run. The full operating system can then run on the top. This includes everything from a simulated CPU and RAM to data buses, disk drives and network adapters. Simulation is computationally expensive, so virtual machines typically have significant overhead. So if you remember, in many of our videos, when we do the testing or review of Linux distribution, some of the Linux distributions run very slow as a virtual machine. So that is because the computationally expensive. So whenever you create a virtual machine, it is a computationally expensive, and some of the virtual machines won't run because the performance becomes lagging because their code is not that much optimized. So best virtual machines are those which run on Linux. So you have got a Linux container or a Linux virtual machine running on Linux, but on Windows containers are not that much good, but best performance is when the containers run on Linux only. So it is given here. So the containers are best suited to and run best on Linux. So it is given, it is known fact. So the performance of containers will be always better than the virtual machine which is running on a hypervisor. So containers, that's why they have got a wide acceptance in the industry, because they are not computationally intensive and they run very easily, and of course stability is also better, performance is better than your virtual machines on hypervisor like type 1 or type 2 hypervisor. So what is a container? So here you can see a specific application is running on a guest operating system. Guest operating system is itself supported on a hypervisor. Hypervisor is supported on a host operating system, and the host operating system is working on a host machine. So this is the hardware or bare metal. So host operating system is working on bare metal. Hypervisor is supported by the host operating system, and the hypervisor itself supports the two guest operating systems, which in turn support the applications running inside this guest operating system. So you can see a lot of layers are there. It is a top heavy system, and that's why the performance is affected. Whereas in the second option on the right side, the application runs on the container engine. So the container is running, application runs inside the container. Container directly runs on the host operating system. So there is no hypervisor in between. There is also no guest operating system. Instead of two guest operating systems, only one container engine is there. And the host operating system will directly run on the host machine. So this is same. From here things change. So you can see one layer has been reduced, and the guest operating system, two guest operating systems are completely removed by a single container engine. So there will be definitely a performance benefit here. A container is similar to a virtual machine in that it contains and runs software in an isolated environment on a host system. However, containers replace traditional hardware virtualization by relying on the host operating system directly. So virtualization, hardware virtualization is also not there. So that increases the system performance. Containers share the libraries and binaries of the host operating system. So what happens in first case, the guest operating systems will also contain the libraries of their own. So that makes them very heavy. Whereas the container engine does not contain the libraries, system libraries. It uses the system libraries of the host operating system. So you can see the size of container engine is very small as compared to the guest operating systems and the hypervisor. And the containers will only contain libraries and binaries of the host operating system. The containers share the libraries and binaries of the host operating system, and only the resources and dependencies needed to run the specific application they contain. So they will contain some support files, but that is only specific to the application they contain. This means that no need for a full operating system per container, as all containers running on system can share the single host operating system by retaining the segregation you need to get within the virtual machine. So you can see the segregation is here. So these two applications are running segregated on a container engine. Container engine is also segregated from the host operating system. So it is very safe, and it is we can say hacking proof also. It is difficult to hack such systems. Containers access the host operating system through a container engine, which manages running containers and controls their access to the underlying operating system. So this is the security that is provided by the container engine, which controls their access to the underlying operating system. This might include enforcing security between containers, granting or denying access to the operating system files or the network connection. So this security can be customized as per the needs of the situation or as per the needs of the users or the system administrator at the site. What are some trade-offs for using containers? While virtual machines and containers are similar, using containers does have its drawbacks. For one, virtual machines are considered more secure, as the surface attack to escape the virtual machine is significantly smaller and harder to penetrate. A container might not be suitable for testing out malware. So if you want to test the malware, virtual machine is the best. Whereas the container might not be the best to test out malware, because you see the supporting files, the supporting we can say specifics are very less. Whereas the virtual machine, it is a completely we can say it contains a complete operating system as well as the application package. Whereas in virtual machine, only the application that is running on that container and the specific support libraries are there. The major benefit of using containers is that they are lightweight. Avoiding the need to virtualize an entire operating system means minimal startup times and reduced system overhead. This means that many more containers can run on one host, which is not possible with virtual machines. Because the containers don't have full operating system, they can be easily packaged into smaller images and distributed. So we can create the images of containers with a, say, specific applications and the dependent, you can say dependent files, dependent linker libraries and all those things, dynamic link libraries and all those things, and we can distribute as an image. So you can download that image from the web, you can install it on the system of your choice, you can spin up that container, you can configure the application, and you can configure the startup and shutdown times, everything. You can even schedule it, so it will just keep on running. There will be minimal issues because it is very lightweight, and you can have many such images, that is the containers running on a single host, and it is very easy to distribute. So what happens if you want to migrate the container from one system to other system, you can just create a copy of that container image that is running on your system, take it, you can distribute it via the web, or you can take it on some, say, USB or things like that, or a hard disk, and then you can just migrate it to the other machine. So Docker is also one type of container. So in the next video we will start with what is Docker and those things, and we will be installing the Docker. So the instructions are given here, how to install a Docker, how to check the status of Docker, how to do the you can say full sample application and run it on the system. All those things are given here, and how to keep the containers alive, all those things are there. So we will do one by one. So there will be series of videos, and then you can see here that this is the page docker.com. so there are some manuals given here also, so we will try this also later. First we will complete the XDA developers manual, and then we will go over to the Docker manual. So it will be a very good exercise, and the newcomers, freshers especially, we were studying in colleges, they can check out for themselves how the containers, Dockers work. So it will be a live experiment on the system. They can watch the video. So now I will stop the video here. See you in the next video. Bye bye.